new information. So this is new 10.2 stuff. And a fraction in a square root. Sometimes they're very, very friendly. Anybody tell me why this one is a very, very friendly one to deal with? The numbers that are involved. What do you think, Michael? What kind of numbers are they, those? From our list, what are those numbers called? Do you remember? All right, we have perfect squares. This is the square root of 4 over the square root of 9. That's what this problem really is. That turns out to be a 2, and that turns out to be a 3, and that one is finished. I wish they were all that simple. But sometimes they are that simple. So let's do one more of those. We could have 100 over 144. Oh, I'm being far away from the mic. The new computer is what breed? Well, times 12 is 144. This does reduce to 5, 6. So you do want to reduce it if you can. You can. So when they're that easy, hip hip hooray. So if they give you a problem with the combination of letters and numbers, so like 36x squared over, let's say 9m to the 6th, this won't be, don't let it be too hard for you. Remember, just rewrite it. 36x squared on top, 9, and just do these two little problems, and all will be well. Notice 36 is a perfect square, 9 is a perfect square, no big deal. So Ryan, what do you think for the top? For 36, Ryan. What times what makes 36? 6. Okay, so that's the 6, and what about the x, Kevin? X squared. Just get x, and then on the bottom page here, what are we going to get? Very good. So we knew that that end of the 6 would turn into, and that's the end of this problem, with the exception of what? What do we need to reduce? We got to reduce a little. What does that actually turn into? Michael, do you know? What does the 6 over 3 turn into? All right, so it's 2x over m to the third. Because do I need to put the 1 under here? No, I don't need that 1. So this is the best answer. So the homework has some letters in it. So let's see. We'll do 40 over m to the 8th. Just like before, write it as square root of 40 over square root of m to the 8th, and then do both of these problems individually. Somebody go ahead and tell me very quickly what the m to the 8th part is going to be. Daniel, do you already know what that is on the bottom in our denominator? Very good, so that's taken care of. And then up top, what's our perfect square that'll go into 40, Lindsay? A perfect square will go into 40. 4. So it's 4 times 10. Our perfect square happens to be the 4. What does that 4 come out as, Paul? Correct. So we're going to end up with a 2 outside up here and a 10 inside and an m to the 4th, and you're finished. That's very similar to 2 of the 3 homework problems. Okay, so this technically is not in the homework, but this is what you would need more so for the EOC than a lot of the stuff we've been showing. If you've not done this, this is much more complicated. You just got to watch. Here's our situation. Please notice that both of our numbers this time are not perfect squares. If they had been perfect squares, that makes them easy, like the first couple we did. Remember when we went back over here? These guys, these were so easy. You just square root of 4 was 2, square root of 9 was 3, square root of 100 was 10, square root of 140 was 12. Yay, we love those. Okay, this is not that. 8 and 3 don't work that way. So if we rewrite the problem like we've been rewriting them, that's the problem that we have to deal with. There is a rule in square root land and fraction land. Fractions are not allowed to be finished and done with a square root in its denominator. Every single fraction in the world, when it's simplified fully, will not have a square root in its denominator. Just like, remember how when we have problems that look like this, we say that you're not finished? Why aren't we finished here, Sarah? Correct. And you've learned how to get rid of the negative. Do you remember, Pedro, how to get rid of this negative? Right. So you could multiply both sides by a -1. So that's a multiply. And that would make that a positive. Now this is a negative. You learned how to finish simplifying. So we now need to learn how to finish simplifying when you have a square root on the bottom of a fraction, because it can't stay there. This is how you do it. You're going to multiply the top and the bottom by the denominator. Whatever this denominator is, that's what you're going to use. Now for a candy bar, so this new skill right here now falls back on old stuff. So old stuff is multiplying fractions. When you multiply fractions, you just go straight across. So that gets you the square root of 24. And then down here on the bottom, if I multiply a square root of 3 times the square root of 3, what does that get me, Michael? Well, that's the final answer. Square root of 3 times the square root of 3 is the square root of 9, but what is the square root of 9? Michael, go ahead. It is 3. This problem here is just the number 3. Did you notice now the square root sign is gone? We got rid of our square root sign. Yes, 3. So now I need to break this down. So what is that? 9. I'm blanking. Ooh. So 4 times 6 up here, keep my 3. Which one of those numbers Paul's going to get out of there? All right, this 4 is the perfect square, so it's going to come out as a 2, leaving our 6 inside, and that 3 is still down there. That is your final answer. You can't reduce a 2 and a 3. That's 2/3. You can't reduce it. So we're going to do one more of these, and then we'll be done. Okay, we'll go a little faster this time. Let's say we have 5 and a 7. Numbers could be huge, but this is what we're using. Remember, this is the square root of 5 over the square root of 7. You can't leave it like that, because one of the rules of mathematics is that fractions do not have square roots in their denominator. So what are we going to multiply the numerator and the denominator by? Megan? That's square root of 7. Go ahead. Square root of 7. That is a 1. We multiply by 1 doesn't change anything. It's just going to make it look different. So I'm now going to multiply across like you do with fractions. Does anybody remember what magic thing is going to happen down here in the denominator that's really, really easy, Randy? What's the square root of 7 times the square root of 7? What the square root of 49 is? Right, so this becomes a plain old 7 down here on the bottom, because the square root of 7 times the square root of 7 equals the square root of 49, which is 7. So that's where that 7 came from. Up here, it's the square root of 35. Guess what? We got lucky. Because none of our perfect squares will go into 35 evenly. 4 doesn't, 9 doesn't, 16 doesn't, 25 definitely doesn't, so we're finished.